picking 10 students and I'm recording their weight. So these are their weights. I'm going to call these Y's, and there's a reason for that. These are Y's. These are weights in pounds. If I were randomly to select one other person, what would be a good prediction for her weight, for his or her weight? If these are the values that I have and one more person walks in the room, what would be the best guess for their weight? Do you really have a good guess? No? What would be a value that I could use from all of these that might be a good value? What types of things can I calculate from data? The mean. Don't you think the average might be my best guess? So if I were to randomly select one more student, what would be a good prediction for his or her weight? The mean. So I'm going to find Y bar. So I can do one variable stats. But first I better put this in a list. So second, stat edit. And I'm going to put, I actually already have them here. I have I put my weights in, these weights in list 2. And if you're doing this, and you should, put your weights in list 2. Because they're going to be the Y values. That'll make it easy. That way we're all on the same page. So then we can do stat calc 1, just one variable stats, and tell it it's in list 2, and then calculate. And all we want is the mean. The mean is 153.6 pounds. So my best guess for the next person would be 153.6 pounds. But this is not probably going to be right. So, question is, typically how far are all of these weights from the mean? Well, that's the standard deviation. So what's the standard deviation? Well, the formula, the standard deviation of these Y values would be the square root of the sum of the difference between the Y's and the mean squared all over n minus 1. Now I'm just writing the formula down to refresh your memory. But we already have the standard deviation calculated here. It's 39.58. So basically, if I were to guess the next person's weight at 153.6 pounds, I would have a range of error. Standard deviation is like a range. It tells you, like here's 153.6, there's the mean. It tells you you can go 40, plus 40 or minus 40 from there. That's how far away you'd expect the values to be. So they could be off by 40 points high or low, 40 pounds. So, question, is there a way to improve my prediction? In other words, is there a way I can reduce the standard deviation? Yes. Use another variable to predict weight. Use another variable to predict weight. So, alright, so here are the heights. These are going to be our X values. Here are the heights in inches for those 10 original students. So for those 10 original students, I now have their weights, or their heights as well. So, we want to sketch a scatter plot, so that means I'm going to go to Stat Edit, and I'm going to enter all those X values in list 1. I'm going to enter the heights in list 1 now. Alright, so sketch the scatter plot, so second stat plot. Sketch the scatter plot. I have list 1 and list 2. If you have that other regression line in there, just hit Y equals and clear it. So, okay, so here's my scatter plot for this data. And this would be the height in inches and the weight in pounds. So now I'm going to do stat calc 8 for list 1 and list 2. and I get my regression equation is y hat equals negative 447.65 plus 9.25x. So the y hat is the weight and the x is the height. So now to get that on my graph, I go to my y equals and I hit negative 447.65 plus 9.25x. The x button, remember, is this xt theta n button. Don't alpha x or it won't graph. And then hit graph again, and it draws that least squares regression line in there for you. So notice we have some residuals. Okay, we've got all of these residuals. So using height to predict weight, do you see a positive relationship? Like as people get taller, the weight is a bit more. So it would probably be a good predictor. Okay, if we use height to predict weight, it would probably be pretty good. So what we're going to be asked to do now is find exactly how far off those residuals are from the line, which is the standard deviation of the residuals. So we are going to learn how to calculate the standard deviation of the residuals. The standard deviation of the residuals, the little variable we use is S, or S sub E. And that formula is the square root of the sum of every y value, every observed y, minus every predicted y squared. In other words, every residual, y minus y hat, every residual squared, divided by n minus 2, and then square root it. So we're going to learn the process to calculate this. So to calculate the standard deviation, we have list 1, we have the data. List 2, we have the y values, we have the x's, and we have the y's. I'm not going to write them all down here. I'm just going to tell you what to put in each of your lists. So now what I need to do in list 3 is I need to get the y hats. So these are actually just instructions on how to do what you're doing, and I'm going to do it along with the calculator. So stat edit, I'm going to go to list 3, and in the heading of list 3, I'm going to put in list 3, I'm going to put all of the predicted values. What I have from my formula, I have in list 2 already, I have the y's. In list 3, I'm going to get the y hats. So list 2 has the y's, in list 3 I'm going to get the y hats. So that's all the values that would be predicted using my calculator. If I put all of my x's into the regression equation, which remember y hat was, what was it? Negative 447.65 plus 9.25x. Now, it's not x though. The x's are where? Where are the x's? List 1. So what we're going to type in the heading of list 3 is list 3 equals negative 447.65 plus 9.25 times list 1, or wherever your x's are. Wherever your x's are, whatever list they're in. And then hit enter. So you're going to type in the heading of list 3, negative 447.65 plus 9.25 times list 1. And hit enter. And it automatically calculates all of those values and puts them in there for you. So now in list 2 we have the y's, and in list 3 we have the y hat. So now in list 4 we're going to take the y's minus the y hats, and the y's are in what list? So we're going to take list 2 minus the y hats. Where are the y hats? 3. So now in the heading of list 4, I'm going to type in second list 2 minus second list 3 and hit enter. And it automatically fills all of those with the residuals. Finally in list 5, I'm going to take list 4 and I'm going to square it. So now what I've actually calculated is I've calculated the difference in the y and the y hats, and now I'm going to square it. So list 5 is list 4 squared. So go up to the heading of list 5 and hit second list 4 squared, enter. And what it does is it squares all those values. And I'm actually going to write all those down now, and this is exactly what you're going to have to do. So you should have them in your list and be copying them down. Just keep going down. Some of them are kind of small. Okay, there's all of them. So now what do I want to do with that? If I'm finding S, and I'm going to finish this up here, if I'm finding this calculation, I've done this, what does this mean that I need to do with all those numbers now? Add them all up. So now I need to add all those up. So now I just go to my normal home screen. I'm going to add all those up. I don't think that's quite right. I think I messed up on one of them, but it's approximately 300, yeah, no, that's okay. 3828.88. That's fine. So basically it's 3829. So I'm going to take that, that's under here, it's also known as the SS residuals, and I am going to square root 3828.88, and what am I going to divide it by? What was n to start with? How many people did we have to start with? N equals 10, so n minus 2 is 8. So now I take second square root 3828.88 divided by 8, and I get that the standard deviation of the residuals is 21.88. Now, the question is, have I successfully lowered the standard deviation from my original data? Well, flip the page back over here. My original data was the mean, and then the standard deviation of just the y's was what? 40. So have I successfully lowered the standard deviation by using another variable? Yes. So that is standard deviation of the residuals and how to calculate it.